one P. Up to half of yang.
Okay, do you take out your textbook? I'd like to give you some revision paper so that you can start early if you like to start your revision. So in total, there are 4 different items. A21. Okay, so you should be receiving a so you should be getting a 2021 paper, 2022, then a part 1 paper, and a part 2 revision paper. Okay, make sure you get all 4. Try to get the help of few of you, Ryan also. Just come to, okay, go Beatons. You help me count the correct number including yourself, and then you pass down the rope. Count the correct number for each section. Sorry? Yeah, it's different.
Can you stop like moving stuff around then? Because I'm forgetting how many can I put down.
Okay, once you receive the item, make sure you put it into your bag, file it somewhere so you don't lose it.
Okay.
Okay, double check you have 4 items. Everyone double check you have 4 items. Yes. Sorry, Joe, are you missing something? What is this? Did someone keep for EV? Okay, I need you to double check that you got the correct items. Part 1, Part 2, 2022, 2021. EV's best friend? Yeah, I shall not make that claim. EV's buddy? Okay, go on. Thank you. You can write my name. Okay. Your other teachers got give you revision paper also. Go on. Yeah, I know. Okay. Sorry. Okay, so I understand there's a lot to do. I will start to go through in around week 2 of your term 4. So term 4, week 2. Okay? But I give you now so you can start if you like to, then you don't have to rush again. Okay, could I get you to do it in this sequence? So you start off with this one, number 2, 3, and 4. Okay, go as the sequence goes. Okay? I will go through the papers, after which part 1, part 2. Part 1, part 2 are not exam papers, they are just revision questions. Okay? At the end of the day, we will upload all the answers online. The event that we don't go through all, you can still go through the answers online. But just go in sequence. 1, 2, 3, 4. Don't need to do all first. Maybe this week, if you feel like it, you can start on 1. Next week, start on 2. September holidays, you do 3. Week 1, you do number 4. Okay? Every week, do 1 paper, and you'll be done already. Okay? Okay, today we're going to gradually move on to the next segment of the chapter. Before we go on, we need to do a quick revision with all of you. So, start to recall what we learned last week about ions. I'm going to do a quick test on your current knowledge. What you will require is your periodic table. Okay? So you look at your periodic table, prepare yourself up. I'm going to ask you things from what you learned last week. From things like group, period, how many valence electrons, how many electron shells, so on and so forth. Okay, so take your textbook, flip to the back, we practice using the periodic table. Once again, the better you are at your periodic table, chemistry section is practically open book. Yeah? For students that do not use it, the periodic table is just another sheet of paper during the exam. But I want you to feel like you have an open book, all the answers there. Okay? So let's practice. But don't shout out the answer. You think for yourself. Mental prep up. Okay, so first level of prep. Can you tell me which period and which group oxygen is in? Everyone do a quick practice. Which period and which group is oxygen in? Okay, let's enjoy. Period 2 and group 16. Agree? Period 2 and group 16. Well done. Okay, next one. Which group and period is potassium in? Which group and period is potassium in? Interestingly, potassium, even though it starts with P, the symbol is a K. When I was a student, I always had trouble finding this. So potassium, group and period. So? Sorry? Group 1, period 4. Correct? Okay, well done. Next one. Which group and period is bromine in? Bromine. symbol BR. I've got two boys. Sorry, I've got one girl, one boy. Okay, Vera? Period 4, group 17. Good, loud and confident. Correct? Okay, well done. Last one for this section of the practice. Which group and period is magnesium in? Magnesium. Binat?
Period 3 and group 2.
Well done. Okay, period 3 and group 2. Yes, you can clap. Okay, very good. So first level of practice. Now let's go to the next level. On what kind of information can you get from knowing the group and period? So first level of information you can get up. How many valence electrons or outermost shell electrons are there for the element phosphorus? I say again, how many valence electrons? This is how you spell valence electrons, which also means outermost electrons are there in the element phosphorus. And how do you find out the information fast? Let's go. Outermost, okay, it's not entermost, outermost. For phosphorus. Okay, so I ask, let's ask the girl. Rushe? Okay, Rushe says 5, correct? Okay, how do you tell? Because group 15. When you look at group 15, you look at the second number. Okay? At least for those with double digits. That's how you can find out. Okay, well done. Next one. How many outermost electrons are there for, let's go to magnesium again. Magnesium. Ryan, how many outermost electrons are there for magnesium? 2? Okay, for a moment, I heard Brian say 87, so I stunned. Okay, well done. Next one. Aluminium. How many outermost electrons are there for aluminium? Boy, girl. Anshika? 3. Well done. Because 30, so you look at the second number, 3. Last practice. How many outermost electrons are there for the element neon? So you go to boy. Neon. Jack? 8. Okay, well done. So that's one category. Next one is on outermost shells. How do you tell how many outermost? How do you tell how many electron shells the element uses? Okay, how many electron shells does the element uses? What do I mean? If we look at, for example, sodium, how many shells does it have? How do you find that information? Okay. So first and foremost, how many electron shells does silicon have? How many electron shells does silicon have? Okay, just now we are end off with that. Achika, so let's go to a boy. Oh, Jack. Okay, Jack. So let's go to a girl. Jack, sorry. Kara. How many electron shells does silicon use? Three. Yes, uses 3. How do you tell it uses 3? Because it's in period 1, 2, 3. Okay? Anything in that row is going to have to use 3 electron shells. Okay, let's go to the next one. How many electron shells does nitrogen use? Nitrogen. So let's go to next one. Boy, come here. 2. Okay, well done. You're getting the hang of it. How many electron shells does helium use? Helium. Let's go to go. Ionic. 1. Okay. I think I shall stop there because that's as much information as we can get. Okay, last practice. Let's go to electron configuration. So I want to know the electron configuration. What am I asking for? I'm asking for these things, the 2.8.1, this kind of thing. Okay, so let's practice that. First one, what is the electronic configuration of, maybe let's do it together. I'm going to pluck one from a few groups. So I'm going to take some from group 1, group 2, group 13, next one, group 15, group 16, group 17. So you can stand by. I'm going to ask from all these categories. Okay, these are the ones I'd like to test you on. You quickly do a quick practice. First one, tell me for lithium, magnesium, sorry, I prefer sodium. Okay, what is the electronic configuration for all these elements? Ready? Yeah, I should be able to hit all of you today. Everyone gets a goal. Let's begin first with sodium. So we look at sodium. We see a few numbers inside. We see 11 on top, 23.0 below. Okay, how can you make use of the information? So sodium electronic configuration. Adora? So how you will reply me, you will say 2 dots, and then you go on and go on. Okay? Adora? 2 dot 8 dot 1. Agree? Yeah, agree? Oh, okay. And last week we left off at this. I taught you how to draw a dot and cross diagram. Remember? What will a dot and cross diagram of sodium look like? We just focus on the outermost electron, so I'm just going to do one dot. Remember? Okay. Let's continue on. Magnesium. What's the dot? Sorry, what is the electronic configuration? So Dora, let's go to the boy. Boom. Okay. Okay, I have to admit until now I cannot remember your surnames. So
What?
I don't know which one is Liang, which one is.
Just call it.
So Ethan with the shorter hair. Okay, Ethan, magnesium, what is the electronic configuration?
Magnesium
2 dot 8 dot 2. Okay, how many dots should I put for magnesium in the dot and cross? This is a dot and cross diagram of sodium. So for magnesium, I'm just going to put 2 dots because it's trying to show you how many valence electrons it has. Okay, a dot and cross diagram. Alright, you all have done all of this, yeah? Every single one we can possibly do. I'm trying to prepare you for every possible element that you could be tested for. Let's go for aluminium. What is the electronic configuration of aluminium? Aluminum. Boy, Megan? 2.8.3. The dot and cross diagram should look like that. Aluminium has 3 outermost electrons. 3 outermost electrons. The next one, nitrogen. Let's go to boy. Again. Nitrogen. 2.5. Agree? That's all. 2.5. So outermost electron should have 1, 2, 3, 4, and 5. Let's go to, I want to change symbols. Okay? All of these I shall use dot. I'm going to use cross for these fellas. 1, 2, 3, 4, 5. Next. Note this, it still corresponds 5, 5. So that's how you find out outermost electrons. Next sulfur. Let's go to a girl. Olivia. 2.6. Very good. 1, 2, 3, 4, 5, 6. Fluorine. So the boy, Ivan. 2.7. 1, 2, 3, 4, 5, 6, 7. Let's check. By right, you see 2 electron shells. So nitrogen, sulfur, and fluorine should be all in period 2. Okay, Olivia? Alright, okay, I made a mistake. So 2, 8, 6. Better? Yeah. Okay, so sulfur, period 3. Yeah, period 3. Nitrogen and fluorine, period 2. Period 2. Because you see 2 electron shells. Okay? Feeling confident about chemistry so far? Okay, if not confident, then we just keep practicing. Really, it's all about the periodic table. Not to read it, so much information can be extracted out of it. That is practically open book. So this is where we left off last week. Last week we talked about how ions form. Okay, last week we talked about how ions form. And I think we went through 2 categories of ions. Okay, we have categories of ions that form from metals and ions that form from non-metals. I'm going to show you in a while how you can find out which are metals, which aren't metals. But the ultimate aim of all of these elements is that they want their outermost shell filled. Remember? All of these elements want their outermost shell filled. So for example, they want their outermost shell filled. What would be the easiest way to acquire that? When we look at groups 1, 2, and 3, notice that in the outermost shell, they have very few electrons. Is it easier to lose or gain electrons such that I end up with a full shell? It's much more easy to lose, right? For example, for sodium, if I were to lose 1 electron, all I'm going to be left with is 2.8, and I have a full shell now. How do I draw the sodium ion in dot and cross diagram form? It will look something like that. Sodium. The moment you form an ion, I want you to bracket it, and then you put the charge on the top right hand corner. It is a 1 positive charge because you lost 1 electron. So let's do a quick revision. Everyone stand by. I'm going to invite a few people up to draw the dot and cross for these ions, as well as write the electronic configuration below. So if you've not been caught, you're going to come up soon. Yeah, I will not call the same person. Okay, I would like the dot and cross diagram for these elements. So 5 people in total. I've not got you yet. So now? Oh, you won't hear. Okay. Okay, you may need to watch the video so that you can catch up. Right? Will you pick anyone? Draw for any. Not even referring to anything now. It's going straight up. Have I called Yumi? No, I haven't called Yumi. Okay, Yumi, choose anyone you want.
Regan.
I haven't called Regan. He very bad. You stumble your friend.
Now I can call Regan.
Regan, choose anyone. Anyone that you feel confident.
Yeah, let's go. Yeah, Regan. Regan go draw.
The girls have claimed the ones that are easier to do. Okay, Regan, so you have these. Okay, maybe you pause for Regan. So we look at all of these. All of the girls have chosen to lose electrons. So from sodium to sodium ion, lost 1 electron. From magnesium to the ion form, we lost 2 times electrons. This one, aluminium, we lost 3 electrons. And you got the charge right, because if you lose 2 negatives, you become 2 positive. If you lose the negatives in your life, you feel very positive. Okay, remember that? Lose the negatives in your life, you feel positive about yourself. Okay, so when you look at nitrogen, sulfur, and fluorine, it's easier to gain electrons. Yeah? How many more does it need to gain to get a full shell? How many more does sulfur need to gain to get a full shell? As well as fluorine to get a full shell. Okay? We can pick and choose which one you prefer. The easiest one. Oh, I like the way we're going to stick off his specs, right? Like he's ready to. And then he puts it back on. so that you can see much more. Okay? You can choose fast, because your friends will claim the next one. Yeah? Okay, you can choose. You can pick before Regan picks. Oh! Yes, Regan chose the hardest one. Okay. Choose. Joe? You have the honor of doing the last one. Thank you. Remember, you got the charge, correct? Alright, yeah. You have to draw the surrounding electrons. Then you must draw. Funny joke. Then you have to draw how many electrons got in. Yeah, so you gain one electron. Very good. Very good, that's it. Well done. Yeah, to say, those that are doing negatively charged ions having cover. Can we give that a round of applause? Okay, all happy? Yeah? Let's check. 1, 2, 3, 4, 5, 6, 7, 8. It gained 1, 2, 3 electrons. Very good. Therefore, 3 minus. If you gain negatives in your life, you become negative. Okay? Sulfur gain 2, 2 minus. Fluorine gain 1, just a 1 minus. It's very well done. I have to say the N ions are the toughest ones to do because they have to draw so many things. So I've already given it away. What do we call such ions? We call them onions. Okay, N ions. What do we call the positive ones? Cations. Cat ions. Okay, so this one is the cat meow positive pause. Okay, yeah. Okay, then N ions, the negative ones. Okay, well done. So this is where we've accumulated our knowledge so far. Today we're going to build upon this to the next step. Because now that you know your foundation, you can really start doing chemical reactions. Have you always wondered when you go into the lab, if I were to provide you chemicals, which ones can mix with each other to form something new? Yeah. You have, finally we are getting there. Yeah, since I met you in the start of the year, all you'll be asking for is, can I make an explosion? No, we are not. I need to train you on what you need to know, or which ones you can mix, then I can be sure you don't end up blowing stuff up. Oh, very clear ion. Well done. Okay? I tell you right now, you have enough knowledge now to know which chemicals can chemically react with each other to create something new. You are now an alchemist, a chemist, someone that can create new things. What? Okay, so but how do we go on doing that? First and foremost, I would like to direct your attention to the periodic table. One more information you can gather from your periodic table. First thing I would like you to draw in your periodic table is to find out which elements are metals, which are non-metals. Okay, everyone look at this black staircase. I would like you now flip to the back. Use a highlighter or anything you prefer to draw this staircase in. This staircase is important information because it gives away and tells you which elements are metals, which are non-metals. Okay, draw that staircase in. Okay, then the next question you ask is, then what are the metalloids? How come we color the yellow ones? Some students, once they see this periodic table, some of them, if you prefer, you can even start coloring your periodic table. If you are a very visual learner, you can go ahead and do that. Okay, you will have noticed that we highlight some of them yellow. Metalloids. Metalloids are a special category of elements that have a little bit of properties of metals and non-metals. Okay, that's all I'd like you to know for now. They have properties of both. There's one element that does not fit anywhere. You see one time hydrogen floating on the top. Yeah, in your periodic table. Hydrogen is a non-metal. mean, you're experiencing yourself, there's hydrogen gas all around you, right? Cannot be the metals are floating around. Okay, so hydrogen is a non-metal. So very interestingly, actually in reality, on Earth, planet Earth, most of our elements are metals. Yeah? Okay, I wouldn't say so in terms of amount, but at least when you look at elements, there are actually more metals than there are non-metals. Okay, more metals than there are non-metals. In fact, you look at periodic table, this whole red section and below, it's actually all metals. When we want to look at non-metals, it's actually a very small category. Today, I'm going to teach you how you can figure out which kinds of elements can react with each other to form new, what we call compounds. You still remember the word compound from long ago? Yeah? Last time I taught you the words element and compounds. What are elements? Elements is what we've been studying so far. For example, this is an element, fluorine, it's an element. All of these are elements. Some elements are metals, some elements are non-metals. Today, we go one step further in our chemistry journey. No way. Okay? Ryan, thanks for the commentary. We go into compounds. What happens if we learn how to combine metals and non-metals together? Well, we end up forming something new. We end up forming what we call compounds. And today's kind of compound I'm going to teach you how to form are what we call ionic compounds. And you'll see why we call them ionic compounds very soon. Okay? I'll give you an example. Do you know sodium chloride, or what we know as table salt? This is an example of an ionic compound. It is made up of a metal and a non-metal. So I'm going to teach you how you can figure out what kind of metals and non-metals you can put together to form new kinds of ionic compounds other than table salt. Yes? So where are we at now? I've progressed to the next chapter, chapter 11. We are going into the chapter of chemical bonding. We're going to learn how to bond different elements together. We're not going to learn it, but you can, with this information, you can know how to create it. Okay, so today's lesson, we're going to break it up into a few parts. First part, I'm going to run through a simulation. Then, as with every simulation, I'll let you play with it after that. Okay? And as with every simulation, somehow you always find a way to hack it and to destroy the simulation.
We are living in one.
Can interns ask, are we living in one? Okay, I have no idea. My dear Emily, I just realized you still have your props from long ago on your table. Except the color seems to be gone. How is that possible? Yeah, but how did the blue become less blue? Interesting. Okay. Let's look at the screen. Later on, you get to play this simulation. Why learn about chemical bonding? For several reasons. First reason, so that you don't create a bomb. Okay? If you know what can react with each other, you can be very careful about it. You don't end up causing a reaction you don't want. Second, why learn about chemical bonding? So that we don't waste chemicals. If you know what can react with each other, you can choose the correct things. You can also choose the correct amount of chemicals to react with each other. Believe it or not, just by knowing this information on the whiteboard, you actually already have enough information to know how much of each chemical to react with each other, proportionally speaking. And then you won't go and waste my chemicals next time. Okay, let's look to the screen. I'm going to teach you how to create compounds of the ionic kind. First and foremost, imagine if I put two negatively charged ions together, anions. Yes, life will be very negative. But what happens if I try to bring two ions close to each other? Watch what happens now. So I'm trying to bring this anion close to this anion. It seems to have a repelling effect.
It's rejecting the other bonds.
Yeah, it's kind of rejecting advancement unless I corner it. Cannot escape now. You've been cornered. Okay, but if this one tries to go towards it, kind of repels it. Can I? Oh, okay, fast. Okay, but you'll still repel. However, let's look at an alternative. What happens if I bring together positive ions and negative ions close to each other? What do you predict will happen? Okay, so I'm going to bring the anion close to the cation. I'm not even that close yet, and they auto come together. And now observe what happens if I try to pull them apart.
They cannot leave each other.
Yeah,
Like
if
each other too much.
we're getting married to each other now, inseparable. Next time your boyfriend, girlfriend, inseparable. I advise you try not to form boyfriend, girlfriend within your class. Okay? Relationship will get awkward. Last time I got shocked. I taught a class for 2 years, blows my mind. I did not know that there was a boy and girl dating each other until I stopped teaching them, then I saw them outside holding hands. Blow my mind. Okay, next one. So when I come to the chapter of chemical bonding, I often talk about relationships. Because really it's a relationship. So we've learned one thing so far. Number one, opposite charges attract and stick to each other. Yeah? Opposite charges, opposites attract. Opposites attract. Like for myself, believe it or not, I'm an introvert. I'm a very quiet person by nature. But when I teach you, I have to be loud. But my wife is the opposite. My wife is a little bit more extroverted, so I'm very attracted to her. I like more extroverted people. If you put two introverts together, I tell you in the same room, they're going to be very quiet. Put two extroverts to each other, they're not going to listen to each other. Okay? And so, people who are very alike, they repel each other. So if you want to build compounds that are ionic in nature, we need to find opposites. Where can we find opposites? In order to form such category of compounds, we need to take elements from the metal category on the left side and elements from the non-metal category, which is this small little section over here. I give you an example right now. For example, let's have a look at okay, agree with me? Those in the metal section, they tend to form positive ions. Those in the non-metal section, they tend to form negative ions. So that's why we must pick one from each category, then they can attract each other when they form ions. So let's have a look at a classic example. Look at sodium and chlorine. Okay, metals form positive ions, non-metals form negative ones. But let's look at a classic example of sodium and chlorine. Sodium is a metal, chlorine is a non-metal. So watch what happens. Let's have a sodium and chlorine. Both are atoms up. But what happens if sodium loses an electron and chlorine, I don't have chlorine here, gains one? What we have not talked about so far is when sodium loses an electron, lose to where? When chlorine gains an electron from where? Why not lose and gain to each other? So for example, look at sodium and chlorine right now. Sodium is going to lose one electron, which is what it prefers. And chlorine will gain one electron, which is what it wants. And this is what you observe. And then some students at this point will say, oh, chlorine became pregnant. Well, this is not the case. You are not yet married. Okay?
It's okay. Thank you.
But observe, sodium now is positively charged, chlorine is negatively charged. What will happen next? They will then become very attracted to each other. Yeah? Or sodium is like, I don't know the guy or the girl, give the ring already, right? Then we're attracted, then they come to each other. That was a very simple way of looking at things. But in reality, when I react chlorine and sodium together, I cannot be right. I can somehow pluck out one chlorine atom and one sodium atom. It is impossible. But what is more possible is if I give you a jar of chlorine gas and I give you a block of sodium metal. You cannot pluck one by one, but you can give you a lot, millions of them. And this is what is more likely to happen. I have a lot of them reacting with each other. And actually all of them can be attracted to each other. Okay, I don't know what kind of relationship this is. Okay. So a lot of them are attracted to each other. Okay, so what I showed you before, that's not really what's happening. In reality, many ions can be attracted to each other. In reality, many of them can be attracted to each other. Okay? But what I'm showing you here is just really a snapshot. In reality, this goes on for millions and millions of ions. Not just a small, it's not just 1, 2, 3, 4 and this small number. Millions of them can come together. When I put a block of sodium into chlorine gas, millions of them will form. Yes? Okay, you told us, can two metals get attracted to each other? The answer is actually complicated, but we will deal with it next week. Okay? So this is in reality what's happening when we form ionic compounds. Many of them will come together, many negative and positive ions will come together. If I look at it in 3D space, this is what it looks like. Here, looks like it's 2D, right? But in reality, it's 3D. Where can I find this same diagram? If you look at chapter 11, chapter 11 on page 58, on page 58 of your textbook, you should see the same diagram here. See the same diagram? On page 58 of your textbook, on page 58 of your textbook, you should see the same diagram of sodium and chlorine attracted to each other, forming a very large structure. There is a name to such a structure. Because such a structure, because it's very big, this structure, it is called a giant, because it's very big. Ionic, because it's made up of ions. Lattice. Lattice means to interconnect. Last but not least, structure. Because such a structure, a giant ionic lattice structure. Because in reality, when you combine metals and non-metals together, they form something really big. Millions of them coming together. Right now, my screen can only show you so few. But in reality, millions of them can come together to form a giant ionic lattice structure. You have a question? Then? Okay. All good? Right now, I'm going to teach you how to write down the chemical formula of ionic compounds. Let's say we combine sodium and chlorine together. Okay, I'm going to change this to chlorine. Sorry, who helped me to do this just now? Okay, so chlorine. What is chlorine? I think it's 287. Okay, gain 1 electron. What if we combine chlorine and sodium together? Okay, I'm going to teach you how to write down the chemical formula. Oh, sorry, actually it's very recent for you. So, this is the chemical formula of sodium and chlorine, sodium chloride. Notice, that if we look at the screen, here I'm going to count how many chlorine ions there are, how many sodium ions there are. So you count with me. So let's start counting. There is 1, 2, 3 sodium ions. There are 1, 2, 3 chlorine ions. In other words, they are in a ratio of 3:3. If I simplify the ratio, what would it be? You end up getting a 1:1. When I write down chemical formulas, I want to show the chemist what is the ratio of these two ions together. So in this case, I write sodium and chlorine. Because it's 1:1, I do not need to write any numbers at the bottom right corner. You will see what I mean if I look at the next compound. Let us look at calcium and fluorine put together. Can you count how many calcium and fluorines there are? Let me rotate. You help me count. Okay, how many calcium are there? How many fluorine? Counted? Okay, just spinning away. Okay, how many calcium?
4.
Let me pause it. How many calcium are there?
4.
4? Okay. So you notice the ratio. Let's count the ratio. There is 1, 2, 3, 4 calcium. How many fluorine ions are there? 8. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Can you tell me what is the ratio of calcium to fluorine? Which one is the 1, which is the 2? Calcium is 1, fluorine is 2. How do I write down its chemical formula? Since calcium is 1, I don't need to put anything. Fluorine is 2, I'll put a 2 at the bottom right hand corner. So that is how we write the formula for the compound. The number at the bottom right hand corner shows you the ratio of the elements present. Okay? Why do we need to know the ratio? Because in reality, this is just a small number. There are millions of them. But we want to know the ratio so that when you go into the lab, you know that I'm going to weigh out roughly the elements in this proportion. So don't waste that. Okay? I know that I need, for every calcium, I need 2 times the amount of fluorine. Yes? Right, okay. Then Kara asks, actually this one, actually 4 is 8 is correct, what, the ratio, correct? But we want you to simplify the ratio. So the last one is not correct simply because it's not simplified, but actually the ratio is correct. So this is the best answer. Following? But I want to show you that even without counting, you can find out the chemical formula. Okay, you all can try this. This is a little bit of math and chemistry. Have you all learned about lowest common multiple before? Okay, so this is a little bit of math and chemistry. Okay, I don't know if we'll find the list. Okay, but you have a look up. Can you tell me if I want to combine together? This one is a challenge, but it's an interesting challenge. So let's say I go to the lab. I ask you, if I want to combine magnesium and fluorine together, what will the ratio need to be? MgCl. You know the ratio? How will you find out the ratio? Do you notice anything about how we derive the ratio? Okay, so here's the clue. Magnesium ions form an ion with 2 plus. Fluorine ions form a charge of just 1 minus. The aim at the end of the day is to end up getting something that has no charge. Okay, so that's a clue. So what would the ratio of magnesium to fluorine ions be? Okay, so I'm going to give the answer for this time round. If I have 1 magnesium and 2 chlorines, 2 times of chlorine, do I end up balancing and creating something neutral overall? Right? Because if I have 2 chlorines, Now I have two negative charges. One magnesium is a 2 plus, together is a 0. So the ratio would be a 1:2. But you don't need to write 1 every time it's 1. Let's try another example. Okay, next one. We slowly practice until we slowly get the hang of it. Let's try to combine aluminium and nitrogen together. Okay, everyone try. What would the ratio of aluminium to nitrogen be? Okay, yeah, make it too easy. Or can you tell where I'm going? Let's look up. Aluminium has ions form a charge of 3 plus. Nitrogen forms a charge of 3 minus. A. Balance? Balance, right? Do I need to change anything? It is as it is. If I send you to the lab right now, you know that I need same proportion of aluminium to nitrogen. Make sense? Okay, you see how much information now you have? You're starting to become a real chemist now. You can really not waste my chemicals. Let's take it up a notch. Let's challenge yourself. What if I want you to combine sodium and sulfur? Sodium and sulfur. Okay, I'd like everyone to try sodium and sulfur. What will the chemical formula be? Doable? You're at the stage I can call names already. Okay, sodium and sulfur. What will be the chemical formula? I feel like I called almost everyone today. Except for Emily. Emily, sodium and sulfur, what will you write? The bottom right corner for me. Sodium's charge is 1 time positive, sulfur's charge is 2 times negative. Which is the one which is the 2? Okay, 2 is to 1. Agree? Okay? Let's try 2 more. The last one is going to be the toughest one. Okay, what do I need if I want magnesium and chlorine? Magnesium and chlorine. Magnesium and chlorine. That's this already. Oh, I did? I did, man? I did. This is sodium and chlorine. I didn't. Okay, who's left? I haven't taught some of you yet. Which one? Oh, you're a very nice class. Point. Help me direct my attention to one. So what is the answer for this? Magnesium has a charge of 2 plus, while chlorine has a charge of 1 minus. So what will the, how can I balance things out? 1 is to 2. Okay, you don't need to write the 1. Everyone agree? Yeah? So if I send you to the lab now, you just weigh things out. Okay? So you see, that's why chemistry is so linked. I need to follow every step of the way. Every time notice when I start a lesson, I practically recap the whole previous lesson. Right? Because everything is so linked. The moment you know all of these parts, you can do the next part, which is the proportions. Okay, this is the ultimate challenge. How do you combine magnesium as well as nitrogen together? How will you do this one? Okay, this one is the one where I say you need a little bit of math, the lowest common multiple. How do you combine magnesium and nitrogen together? Magnesium is a 2 plus, nitrogen is a 3 minus. How then? Your math strong or not? You make your math teacher proud?
No. I'm pretty sure I already felt her.
Okay, then don't fail me. Okay, so magnesium and nitrogen. Notice what I've been giving you is very straightforward so far. But what happens if it's a 2 plus and a 3 minus? If I were to take 1 magnesium and 1 nitrogen, it doesn't match up, what? Right? If I take 2 magnesium and 1 nitrogen, also cannot match up. 2 nitrogen and 1 magnesium also not match up. So how? Anyone solve the puzzle? Emily, you play piano? No, Emily has the answer. Emily, would like to share? Okay, has everyone given a thought? Yeah? Solve the puzzle? Because this is as challenging as it gets. Okay? Okay, sorry, math got you different level. Okay, so Emily, what would be the ratio? Sorry? 3 to 2. 3 to 2. You all agree? Agree? Okay? Magnesium has 2 plus. So if I have 3 times of 2 plus and I have 2 times of 3 minus, isn't this 0? Yeah? And I say this requires a little bit of LCM because at the end of the day, what's the lowest common multiple? It is 6 that you are working towards, correct? So this is as tough as it gets. Everyone okay? Okay, I take a pause over here. You digest your information. You can write down some notes in your textbook. We take a short pause before I move on to the next part. Yes? Oh yes, right. Yeah, it's ready. Okay. Have you got time? Okay, go ahead. You don't want to take photo, don't need permission. Just go ahead. When I give you this short break, use it as a time to chat with your friend, clarify things that you felt that you may not have understood. I'll leave you some time to ask questions in a while before we move on. Everyone feel okay? Chemistry so far? Okay. But you got better and better, right? Yeah. So chemistry practice makes it perfect. Okay, last thing for today. This is what we've learned so far. We learned how ions are formed. They form from giving and taking electrons. we understand why ions are attracted to each other. Last but not least, we learn how to write a chemical formula for ionic compounds. The last step of today, to close off this section of ionic compounds, is to learn how to write the dot and cross diagram for an ionic compound. Okay? How do you write a dot and cross diagram for ionic compound? I'd like to give you an example now. Let's go back to our classic example of, let's look at magnesium and chlorine. MgCl, what's the ratio? Thank you. Okay, MgCl2. Get everyone's attention. This is the last part of today. It's linked to the previous part. Sorry? Yeah. Okay? Alright. So now I'm going to teach you how to draw a dot and cross diagram for this chemical compound. If a teacher were to ask you, can you draw the dot and cross diagram for magnesium chloride? What will you do? All you have to do is to draw for me the ions of both elements side by side and show me the ratio. I'll show you an example. Voice at the back. I'll show you an example. If the teacher were to ask you to draw a dot and cross diagram of this is what you do. All you have to do is go and combine. First, you draw the magnesium ion, 2 plus. Then you draw the chlorine ion with all of the electrons on the outside with a minus. What about this ratio over here? You just put it a big 2 over here. Okay? So that's all there is to it. If we ask you to draw a dot and cross version of this, you just have to be able to draw the ions, then tell me the ratio of it. Again, it's building on the knowledge you already have. That's why I need you to follow me at every step of the way. Let's try another one. So for example, if a teacher were to ask you to draw a dot and cross diagram for, let's do the tough one that we did just now. The tough one we did just now was between magnesium and nitrogen. Magnesium and nitrogen. But right, we've done this before. So I'm just going to ask the ratio one more time for some of you that look like you are not listening. Okay, but now you're listening. Okay, so magnesium and nitrogen, what's the ratio? Do a quick thinking. Just now Emily solved it. Have I called everyone today?
Never called Ivan.
Never called Ivan.
Called me already.
Called already? Yeah, I thought called Ivan already.
You haven't called Joe Huang.
How do you think you can do it?
Joe Huang.
Sorry?
What's the first one?
Okay, so now what is it?
I don't know.
3?
Change the font. PowerPoint.
2. Okay, thank you, Chuna. Okay. Yeah, you can pause now, well done. We missed a whole lesson, but through paying attention, right, gradually picking up the pieces here and there. Okay, 3 is 2. So how might we write this out in a dot and cross diagram form? So same thing, just pick and choose out. So I just need to draw the ions for both. So let's do it right now. Magnesium ion form for dot and cross is this. The charge is a 2 plus. Next, nitrogen one is over here. Nitrogen has this many electrons and it has gained 1, 2, 3 electrons. And its charge is 3 minus. Last but not least, you see the ratios below? Just bring it up to the top. So now 3 magnesium, 2 nitrogen. If you feel, okay, we build confidence, that's the whole point of doing chemistry. Look at page 57. I would like you to try checkpoint 1 now. Okay? Then I will go around and check all your answers. Once I clear you, you are getting more and more proficient with your chemistry. Everyone try page 57. The two examples are calcium, oxygen, aluminium, fluorine. what would its dot and cross diagram be? I'm going to look out for whether you draw the ions correctly, the charge, and the ratio. You know what it's going to do? You know what it's supposed to do? Go to page 57. You draw the dot and cross diagram. Yes. Okay, clearly there, oxygen is an ion, so it should have a lot of electrons. Very good. Okay, two dots because that is the one is healing. Excellent. Yeah. One is to one, yeah. So you need to write the numbers. Okay, you check the charge. Okay, you are correct. Your charge is wrong. Okay, if you don't understand, just let me know. I want you to be with us every step of the way, so it's okay. Just let me know. Don't let it snowball. That's most important.
Why is the only one with that? Because you wanted to answer the line. You don't have. I don't have any data from back.
Fluorine means what you want. Means what negative. Overall negative. Okay, but then the charge of aluminium, what is it? Aluminium is equal to so if there's 3 afterwards, so you want to use 3. Right, so you get 3 plus. Why 3 plus? So that's not how it works. You cannot give up only a little bit. So everyone needs to be balanced. So if aluminium is 3 plus, you need to say the different ratios of aluminium. You need not be 1 aluminium, 1 fluorine. You can have more than 1 fluorine, like to balance out the colors. More than 1 aluminium. So what would be the ideal ratio? Fluorine. But aluminium is a charge of 3 plus, right? Every fluorine is 1. Joe, can I see yours? Okay. Anyone that's not, let me check your answer. Okay, ladies. Okay. Okay. Everyone feeling okay? Okay, let's do practice. Practice makes progress. Okay, now a clean whiteboard, nothing to refer to, only your experience. Let's practice and try to combine more. I'd like you to find a blank page in your textbook. Try out these other chemicals. Yeah, maybe we try a quick practice. Don't call me master. Too weird. Okay. I'm gonna give you 2 elements. In class, I'm gonna give you 2 elements. You tell me if it can form an ionic compound or not. Okay? Ready? I'm gonna write down a few on the whiteboard. You tell me. Sodium plus sulfur. Everyone look to the whiteboard. I'm putting up pairings of elements. You tell me if they can form ionic compounds or not. What is the clue? Ionic compounds can only form between metals and... Okay, so sodium, sulfur. Can or not? Next one. Phosphorus plus sulfur. Can or not? Next one. Beryllium plus oxygen. Can or not? Lithium plus aluminium. Boron plus fluorine. Fluorine plus fluorine. Centroid's face just like quite. Okay? Which one of these can form ionic compounds? Which one of these pairings can form ionic compounds? This is what we've learned today. You need a metal and a non-metal. Then they can form oppositely charged ions. Okay? Let's go. Okay, what about metalloids? Okay, notice I'm not going to focus on metalloids. We'll deal with it when the time comes when you in upper GH. Okay? Okay, sodium and sulfur can form ionic compound or cannot? Okay? Okay, we start to go one more round now. Ready, Chuck? Sodium, sulfur can form ionic compound? Go and think about it. Next one, phosphorus and sulfur. We good? Cannot. Yeah, you're right. Cannot, because both are non-metals. You go and find them. They are both in the non-metal category. Beryllium and oxygen can form ionic or cannot? Okay, Brian? Yeah, okay. Can. Next, lithium and aluminium. Shivani? Lithium and aluminium. Can? Okay, look at the staircase. You draw the staircase correctly. Yeah, okay, so aluminium is very close to the staircase. So look very carefully. Actually, it did not traverse in the non-metal one. So cannot. Metal and metal, they are both metals. Actually, you know what you form when you put two metals together? Yeah, you may have heard of this word called an alloy. Yeah. It's not compound, it's just a mixture. Metals and metals cannot react. They can only form mixtures. Okay, boron and fluorine. Can or not? Boron and fluorine. Must say it properly, no, it sounds like something bad. Okay, you talk. Boron and fluorine. Let me see your staircase. Oh, okay. So boron is kind of metalloid, but if you see it's kind of in the non-metal category. Okay, so it's to the right. So we will still consider it a non-metal. So cannot. Chlorine and chlorine. No, cannot. They are both non-metals. Last but not least, but that's where we started. Teacher. Sodium and sulfur. Cannot.
Yes, because it's non-metal.
Okay, very good. Which is a metal? Which is okay. Very good. Okay. So now you know which elements can form ionic compounds. Let's do a quick practice. Can you draw for me the dot and cross diagram of beryllium and oxygen? Right, sodium and sulfur together. Okay, everyone try now. Draw the dot and cross diagram of these two compounds. Sodium and sulfur, beryllium and oxygen. Just find a space in your textbook to practice. It's the last thing we'll do today. Draw the dot and cross diagram of these two elements. Sorry, these two compounds, these two ionic compounds. Draw the dot and cross diagram. You can use at the end of every part of the textbook, there's one blank space for you to write down things you've learned. You can do it there. didn't ask you to go to you. Either one. I guess there's no fight after all. I think very good sound. Yes. You're kindergarten now. Last time all my teacher right there. Some boy and girl like each other in class and they write secret message to each other. Pass under the table. Then one day the teacher got the message. Then the teacher ran out of class. Last time teacher like, hey, thank you.
He doesn't get it. Why not? They took it last time.
Okay, let's have a look.
He's so easy of highlighter.
All good? Yeah, look at your friends as why? Don't change? Don't change ah? Oh, okay. Sandra, notice something ah? Okay, Sandra is very quick to notice what she needs to change. Very good. Thank you. Everyone right at this? Nothing much to say. The ions are correct. Well done. They wrote the charge and they wrote the ratio, correct ratio. How do I write this in chemical formula? It will go like that, Na2S. Let's look at beryllium oxide. Very well done for the ion. The charge, the ratio is 1:1. So how we write this is a BeO. That's all. Okay? Okay, well done. Tomorrow, lessons to do. Tomorrow, we will move on to the next category of compounds you can form. The more you know, the less you blow on my lap. Actually, I take it back. The more you know, the more you have a moral obligation to do the right thing. Previously, if you don't know, you anyhow makes it blow up, right? It's my fault, I never teach you. But if you already know what can be and what can't, right? Then you are doing on purpose.